In this work, we proposed an automated architecture search framework to explore the architecture of a type of brain-inspired neural network, hyperdimensional computing, HDC. The figure shows the overview of our framework, AutoHDC, which comprises three components. Part A, HDC trainer to evaluate the identified HDC architecture. Part B, the HDC architecture search space to formulate the searchable hyperparameters. Part C, HDC architecture optimizer to control the search process. To the best of our knowledge, this is the first work exploring HDC architecture and formulating the HDC architecture search space. It filled the gap in the optimization of HDC architecture design for given applications. Specifically, the trainer is composed of four phases. In phase 1, input, AutoHDC represents the molecules with a string which is used to describe the chemical structure. In phase 2, encoding, there are further 4 steps to convert the input to a hypervector. At step 1, each string is broken down into substrings of length n, and this method is called n-gram. At step 2, a unique base hypervector will be randomly generated for each character. In the next step 3, we use different rotation shifts to describe the appearance order of a character. At step 4, after rotation, an element-wise operation will be carried out, which is called binding. After binding, the mathematical operation accumulates all the hypervectors resulting from the element-wise operation in one. In phase 3, training, we get the hypervectors after encoding, also called encoded hypervectors, which represent the strings. At step 5, we specify the data type of the encoded hypervectors. The superpose in phase 3 accumulates each encoded hypervector in the same class. In phase 4, output. The results of superpose in phase 3 formulate the class hypervectors. At step 6, similar with step 5, we need to specify the data type of class hypervectors to build up the model. Based on the detailed analysis of steps 1 to 6, we formulate the search space. Throughout the entire process of HDC trainer, there are 8 kinds of hypervector properties or operations during the 6 steps. At step 1, the size of n-gram can be varied. At step 2, the process of base hypervector has 3 properties. First, the dimension of the base hypervector is a hyperparameter. Note that once the base hypervector dimension is selected, the dimension of all the hypervectors in the model will be consistent. Second, the sparsity is the hyperparameter too. The data type of the base hypervector is a hyperparameter, which can be in binary or bipolar format. At step 3, every hypervector rotates n-i times rs elements, where I is the appearance order in the substring and the rs is a hyperparameter representing the rotation shift. At step 4, the type of element-wise operation is a hyperparameter. It is used to bind 2 hypervectors. In the example, we set 4 element-wise choices: multiplication, XOR, and OR. At step 5, we can specify the data type. We can specify the different data type of encoded hypervectors. Last, at step 6, similar to the encoded hypervectors, we can specify the class hypervectors. As the result shows, AutoHDC can obtain the leading scores on all 4 datasets compared with the competitors. On the clean talks, AutoHDC can achieve the score near 1. On the BBBP dataset, the model identified by AutoHDC can gain a 1.37% improvement compared with the deep learning-based method, while a 4.69% improvement compared with the manually designed HDC method. On the base dataset, AutoHDC identifies the model with much higher score than the manually designed HDC method. On the seeder, AutoHDC can get an average 12.7% improvement compared with other approaches. Thanks.